Welcome after the break. Let's continue with the occluded front conditions. Now, like I've mentioned to you before, the system moves from west to east. Now, the cold front tries to catch up with the warm front. Now, very much importantly, you need to remember, as the cold front approaches, basically tries to catch up with the warm front, it forces all the warm air to rise. It cool, condensed clouds, we experience rainfall. Now, we do not experience the warm front conditions in southern Africa because it happens too far down south. But eventually, when this cold front caught up with the warm front, that is known as an occluded front. In this case, we have two different types of occlusion: a warm front occlusion and a cold front occlusion. It's very simple, and I'm quickly going to draw both of them for you on the next page. Now, very importantly, when we look at the cold front occlusion, if you look at the mature stage of a mid-latitude cyclone, there's your cold front, and there's your warm front. Now, grade 12, it's extremely important to me that you know the temperature, what's behind the front and in front of the front. Now, once again, I'm repetitive, but you need to understand, what is a front? It separates two masses of air. Now, if I number them, there's 1, 2, and 3. Now, the cold front is the leading edge of the cold air. The warm front is the leading edge of the warm air. So all the air behind the cold front is cold. All the air behind the warm front is warm. The air in front of the warm front is also cold. Now, this is where it comes in. When this mid-latitude cyclone is in its occluded stage, is when this cold front eventually caught up with this warm front. But now basically what happens? There's a difference in temperature in air. Now, when it's a cold front occlusion, that's the surface. The air behind the cold front, I'm just going to write it over here, is very cold. Now, the air in front of the warm front is just cold. It's very easy to identify a cold front occlusion because the cold front attaches itself to the surface. Very cold air. Please compare my numbers to the synoptic view overlay. Now, all the warm air has been uplifted because the cold front caught up with the warm front. So the warm front attaches itself to the surface. So all the warm air has been displaced. And the air in front of the warm front is just cold. So basically, once again, it works like water. Where will you find your coldest water? On the surface. And as you go higher up, the water is warmer. So because of the very cold air, there's a difference in temperature of the air behind the cold front than the air in front of the warm front. The cold front attaches itself to the surface. So the air behind the cold front is colder than the air in front of the warm front. Keep in mind, it's occluded. All that warm air has been displaced upwards. All of it. Nothing left on the surface. Just cold air. Like when we experience the cold front, all the warm air has been displaced. We only experience the cold front. But keep in mind, we don't experience the occluded stage ever in South Africa. It happens too far down south. Now, vice versa with your warm front conditions. The warm front, once again, if I can draw the synoptic point of view for you, there's your cold front. And there is your warm front. So once again, the cold front is the leading edge of cold air. We say it's cold air. The warm front is the leading edge of warm air. Choose warm. Now, And in front of your warm front, we experience very cold conditions. Now, obviously, if we have water, let's say for instance, for argument's sake, let's say wind, water. If we have wind of, let's say, minus 10 degrees Celsius, and we have wind of 4 degrees Celsius, which wind is going to be closest to the surface? The one of minus 10. The same with water. The coldest water is going to be closest to the surface. In this case, when this front is occluded, the warm front attaches itself to the surface and the cold front against the warm front. Because the air behind the cold front is not as cold as the air in front of the warm front. And obviously, in both occlusions, the warm air has been displaced upwards. If you look at the numbers, as you can see, air is cold over here, all the warm air has been displaced upwards. Then you got your very cold conditions air over there in front of the warm front. And as you can see, the coldest air is closest to the surface. Very importantly, grade 12. If they do ask you to explain it, use the diagrams if you struggle to interpret it, by all means. Keep in mind, let's go back. If you look at the cold front occlusions, the air behind the cold front is much colder than the air in front of the warm front. Now, this is very important. This cold front over here attaches itself to the surface because the air behind it is much colder than the air in front of the warm front. With a warm front occlusion, this warm front attaches itself to the surface because the air in front of the warm front is colder than the air behind the cold front. Please don't get confused between the two. Keep in mind, study the diagrams, and you will be able to answer the questions. Now, on our next slide is a beautiful example of a mature stage of a mid-latitude cyclone. As you can see, it's a low pressure system. Right, you can see the isobars are ovally shaped. And as you can see, it's a gentle pressure gradient. When that isobars are very close to one another, in our next lesson we're going to look at tropical cyclones, it's extremely strong winds. So it's quite a gentle pressure gradient. The isobars are not that close to one another. But very importantly, if you think mid-latitude cyclones, immediately what needs to come up in your head? Right, the system moves from west to east. It moves in the westerly wind belt, that's the reason why it moves like that. And very importantly, it consists of two fronts. The cold front, as you can see over there, and then you got your warm front situated over there. We don't see the warm front in southern Africa because I've mentioned it before, it happens too far down south. And like I explained it to you before, this cold front, it's like cops and robbers, tries to catch this warm front. And eventually, when it catches up with it, it's known as the occluded stage. Okay, so let me just quickly wipe this out and just quickly fill in all the detail that we discussed a couple of minutes ago. So let's just fill in numbers over here. There's 1, there's 2, and there's 3. Okay, what do we know? The cold front is the leading edge of cold air, so that's cold air. The warm front is the leading edge of warm air, so that's warm air. And that, at number 3 in front of the warm front, is cold air. What does it look from a cross-sectional point of view again? Okay, keep my numbers in mind. There's number 1, there's number 2, there's number 3. There's the cold front, there's the warm front. See the cold front moving in that direction. There's number 1. As you can see, cold air. 2 is the warm air. 3 is the cold air. As this cold front approaches, forces the warm air to rise at cool condensed clouds and rains, and we're experiencing cumulonimbus clouds. From a synoptic point of view, this looks like that, as you can see. Now, a synoptic point of view is a satellite. From a synoptic point of view, this is a satellite image. Now, satellite images, you will later learn in GIS, is remote sensing. It's taking basically a photo from far away, as you can see over there. Here you can clearly see the mid-latitude cyclone. Now, if I can draw on the satellite image, there's the 30-degree latitude line, right? This is the cold front, as you can see over there. Now look at the cloud formation over there. Why is there cloud formation? Because that air is being forced to rise. And if you force this warm air to rise, what happens? Remember, it's going to cool, it's going to condense, and we get cloud formation, as you can see. Right? The warm front, as you can see, we do not see in South Africa. The system, as you can see, moves from west to east. And as the system moves, what does it do? It creates rainfall, especially for the Western Cape, down there, southwest and southern Africa. And then over the interior, we just experience the cold snaps and cold stints because all the moisture has been lifted, it condensed, it rained, and we only experienced the cooler temperatures. Now, when they're going to ask you this in the exam, you need to be able to interpret it. Now, this is a synoptic point of view of a mid-latitude cyclone. This is what it's going to roughly look on a synoptic chart. Keep in mind what we've learned in lesson 1. When do we see this mid-latitude cyclones? Only during winter. Okay. The reason why during winter, because in summer, the South Atlantic high pressure has migrated to the south. And if they might ask you a satellite image, as you can see, there's a satellite image over there, and you will find it in your textbooks as well. You can see the band of clouds. Now, if I can just quickly draw this in again, just to make it clear to you. See, there's the cold front. Okay, the warm front we don't see. So the air over here is cold, warm, cold. Okay, now, how to identify the mid-latitude cyclones on a synoptic chart? Obviously, like I've mentioned, overly shaped isobars, distinctive cold front and warm front, like we looked at in the synoptic chart on the previous page. And obviously on the satellite image, you can see the band of clouds as the cold air moves towards the warm air and forces it to rise. And as you can see, you just look at the weather station models. Before the cold front passes over, you will have warm temperatures, and as soon as it passes over, there will be a drop in temperature. Now, as you can see, where the cold front hits the Western Cape of Southern Africa, we'll experience massive cloud cover, torrential rains, thunderstorm activities because of the cumulonimbus clouds. As you will see, the wind backs as well, meaning it changes direction. Just to explain it to you, because as the wind, remember, the cold front tries to catch up with the warm front, so the wind moves in that direction. So it moves from a northwest direction completely west because of the clockwise circulation of air. Now, very much important to me is the impact and the consequences of mid-latitude cyclones. There's pros and cons. Now, when you answer your paragraph questions, always think of economical consequences, social consequences, and environmental consequences. Believe it or not, mid-latitude cyclones It's got pros and cons. It's not a bad thing. For instance, very importantly, economically, it provides rain to the Western Cape, Mediterranean climate. They only experience their rainfall during winter. So all summer long, they're quite dry. So this mid-latitude cyclones provide rain for the farmers during winter. Now, as you know, if you travel down to Western Cape, the Western Cape is renowned for its fruit and wine industry. Now, these rains that fall during winter is very precious for them for irrigation. Now, as you can see, what South Africa is currently experiencing, especially the Western Cape, because of severe drought, they lack water. Now, the reason for that is because there wasn't as many mid-latitude cyclones as before. Now, economically, it can also be a disaster. The reason for it, because the mid-latitude cyclones can create, usually they can come up in families, and we call them cyclogenesis. So as soon as the one mid-latitude cyclone passes over, another one follows. And it can create a lot of precipitation. And meaning, with a lot of precipitation, a lot of rainfall. Now this rainfall can cause severe damage to infrastructure, like houses, like farms, and that can lead to people lose their jobs. Okay, social implications. The floods can damage schools. So that means people can't go to schools. Social implications, people may die because of this flooding taking place. So on the one side, it can bring much needed rain to the Western Cape area. And believe it or not, with the much needed rain, it means the crops will flourish, and it means it will create employment, and we can export the wines and the grapes, and the farmers can make more money. And there will be water for the people of the Western Cape. But as soon as we experience terrestrial rain in an abnormal amount, it can create flooding conditions. And when this happens, it can damage infrastructure, it can cause loss of life, and obviously it costs people money, and people need to rebuild their lives. Now, obviously, if you look at it, flooding taking place, services are disrupted. I mean, the police are on standby, ambulances are on standby. And not only that, flooding can create diseases like cholera, because your sewage systems are all flooded, and it can have a negative impact medically on the community. Now, environmentally, a lot of rainfall can cause basically soil erosion. Topsoil are being washed away. That means the nutrients in the soil are being washed away, and it makes it difficult for farmers to continue their farming. And that means they need to use more fertilizers. More fertilizers means they need to spend more money. Spending more money means they're making less money. So it's a continuous cycle. But please keep this in mind. When you do get this paragraph question, think of the social, economical, environmental impact this mid-latitude cyclones will have on the community. Thank you for watching. Goodbye.